All right, so before we get into example number 4 here, take a look, and we've got an x cubed, and when we divided an x, we're left with an x squared. So we had an x cubed equation, we took an x away, so we're left with x squared as our max. Here there was an x4, we divided an x away, so our max will be an x cubed. And then we just needed to find out what these numbers are. So that's what we're going to do here. We're going to learn a new way. Now this only works, well, the way we're going to teach it, it's only going to work if you have a number like x minus 2 or x plus 3. If you have something with a coefficient out in front, we're not going to learn something like that. So what we need to do for this is you need to write down the coefficients right away. So 2, 1, and negative 15. And then this is a 3, so it's a 3 here, but then you have to had to have subtracted it. So because whenever we do this, we always subtract, subtract, subtract. Okay, so it's a 3 there, but we subtract it. Okay, so let's do this. This is how you do this. You bring down the 2. Very first step. Now we're going to do 3 examples here, so don't worry about getting this the first time. You multiply your diagonals, so negative 6, and you write that here. And then you can put these together, negative 5. Multiply your diagonals, positive 15. Put those together, 0. That's it. So these were the numbers that we were after. So I can write those numbers down, 2, negative 5. And like I said at the very beginning, we had an x squared. You divided an x away, so the biggest thing you should have is an x to the 1. So this will just be an x to the 1, which we won't write. And then this one has no x's. So this is now my final answer. So I found the 2 numbers. There was a 0 for the remainder. And then it had an x squared, so I lowered it by 1. And I started just with an x to the 1. The next one would be an x to the 0, which we don't write because that's just eliminated. So that is our answer. Let's try another one here before we even get too far. So this is a minus 2, but then we're subtracting that minus 2, so minus minus 2, which will just become a positive 2. Now here, the numbers, let's write down. So we've got a 1, x to the 4. We have 0x cubes, and they're missing. We have 2x squareds. We have 0 x's, they're missing, and then we have an 8. So let's just, I want to see, is this a 1, 2, and 8? This is the exact same question that we did up here. Okay? And again, we're really just looking for these numbers. 1, 2, 6, 12. So let's see if we can get those numbers. Bring this down. So multiply the diagonals, add them. 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 And look at that, 1, 2, 6, 12. So we can write them down. 1, 2, 6, 12, and 32. And this was an x to the 4, so we'll lower it by 1 because we're dividing an x away. So we're going to start with an x3 plus, then we can do an x squared, plus then we can do an x, plus then we can do no x's, plus we can do the last one, which was the remainder. And that's it. So this is a way faster way to get 1, 2, 6, 12, and 32 than doing this where we got 1, 2, 6, 12, and 32 as our remainder. So again, how did I do that? You bring down the 1, you multiply your diagonals, do it 2, then you can add this, which is 2. Diagonals, which is 4, then you can add that, which is 6. Diagonals, which is 12, add that, 12. Diagonals, which is 24, add that, 32. And then you just write them in descending order. And it always goes descending order till there's no x's and then a remainder. Now for this one right here, we had these numbers, so it would have been x squared, no x, and then no remainder. 0 divided by anything is just 0, so we don't even bother writing it. So that's how that ended up with no remainder. All right, let's try the last one. So there's a 2, then there's a negative 1x cubed, and then there's 0x squareds, and then there's 0 x's. I don't know why I'm writing plus signs. And then there's an 8. So 2, -1, 2 zeros, and then an 8. And we have a positive 1, but again, we're subtracting these things, so I'll put a minus sign there. So start by writing down the 2. Multiply the diagonals, -2, and then you can add those to be -3. Multiply your diagonals, which is +3. You can add them, 3. Multiply your diagonals, which is -3. Add them, -3. Multiply your diagonals, I'm going to change that, -3, which is +3. Add them, and you get 11. So I have an x to the 4. So, wait, I should write these down. 2, -3, 3, -3, and 11. So I had an x to the 4. So I'll start with an x cubed, then an x squared, then an x. I should put a plus sign here. Then no x, then the remainder. And I should put a plus sign here. And that is my answer. So that is synthetic division. Again, it only works when we have an x plus 1. It doesn't work when we have things like 2x minus 3 or something like that. But if you notice, all of these here, I think all are just x plus 1, x minus 2, x plus 3. Up here, x plus 3, x minus 2. They're all just single x's. X minus 4, x plus 2, x plus 3. So they're all single x's. So we do synthetic division. We do that when we're solving, which we're going to be doing soon. And then in the next chapter, when we do some graphing, we'll go back and we'll do this long division. So I do long division for some parts, and I do, for solving equations, I do synthetic. So that's it for this video. I'll just zoom there, and we can move on with the next video.